A thin paper of thickness 0.02 millimeter having refractive index of 1.5 is pasted on one of the slit in a YDSC. The paper transmits 4/9 of the light energy falling on it. Find the ratio of the maximum intensity to the minimum intensity in the fringe pattern. How many fringes will cross through the center if an identical paper piece is pasted on the other slit too? The wavelength of the light uses 600 nanometer. Alright, now first thing is first that we have given that intensity is given by 4/9 of the intensity falling on it. Fine. So I2 by I1 is written as 4/9, and we know that intensity is directly proportional to amplitude square. So I can write it as A1 square to that of A2 square. So I do have, this one be A2 and that to A1. So A2 by A1 comes out to be 2 by 3. Alright, now what I have to calculate is the ratio of the maximum intensity to that of minimum intensity. So the ratio of maximum intensity to that of minimum intensity is given by A1 plus A2, A1 minus A2 whole square. Fine. So it can be written as 1 plus A2 by A1, 1 minus A2 by A1 whole square. So it comes out to be 1 plus 2 by 3 and 1 minus 2 by 3 whole square, which gives me the ratio as 25:1. That is the ratio of the maximum to that of minimum intensity. In the second part, I have to calculate that how many fringes will cross through the center if an identical paper piece is pasted on the other slit too. Now again, what is happening that if I'll paste a similar strip on the other side, then the path difference at the center will become 0. So I can write n lambda will be equal to mu minus 1 into t, because this is the path difference that was created earlier and that is reduced. So the change in path difference will be this one, and that will be equal to n lambda, so as to calculate that how many bright fringes will cross the center. So just substitute the value of remaining data, because mu is known to me, thickness is given to me as 0.02, and the value of lambda is 600. So solve that, you get the value of n 15. That is the answer.